water molecules. It also accounts for the high specific heat of water. What does that mean? It's really hard to change the temperature of water. And the reason why is to change the temperature, you have to pull those molecules apart. And if you want to evaporate it, you really have to free up one of those water molecules. And so I live in Bozeman, and so Bozeman looks just like this, surrounded by beautiful mountains, but we're at about the same latitude as Seattle. Now, Seattle, instead of being surrounded by mountains, is surrounded by water. And since that water has this high specific heat, what it does is it moderates their temperature. And so this is the average high temperature in Bozeman and in Seattle. And you can see Bozeman is this yellow line. In January, it's going to be in the 30s or high 30s. And then in the summer, it's going to be in the upper 80s, pushing 90. But if we were to look at Seattle, its temperature is really not going to vary that much. And it's rare that they have really icy roads and a lot of snow. And it's also rare that they're going to have 100-degree temperatures in the summer. Why is that? It's the high specific heat of the water that's surrounding Seattle. So for example, in the summer when it gets really hot outside, a lot of that energy is going into the water itself. It's absorbing a lot of that energy. And as it does that, it's kind of moderating the temperature. It's a good reason why you're filled with water as well. If you weren't, our temperature would change radically over the course of even a day. Another property is that ice floats. And you might think, well, that's obvious. But with most matter, with most molecules, when you cool them down, they become more dense and they would therefore sink. But water doesn't do that, and that has to do with these hydrogen bonds in here as well. So as it cools down, it's forming this beautiful three-dimensional matrix which allows it to actually decrease density. Why is that important? Well, if it didn't do that, then ice would settle at the bottom of the oceans and we would quickly be a frozen planet. Another important thing about water being polar is that it's a good solvent. And so this is a PHET simulation. What I'm doing is adding a little bit of sodium chloride or salt to water. And you'll notice what happens, that when we add that to water, it breaks apart into its ions. And so the sodium and chloride ions are actually being ushered away by the water molecules. So if we get rid of the water, it goes right back to that ionic salt. So if we zoom in a little bit closer, what's going on? Well, let me kind of pause it right here. So what do we have? We have this chloride ion, which is going to have a negative charge, and it's going to be surrounded by the positive parts of the hydrogen. Likewise, we have this sodium ion, and so it's a positive charge. You can see that it's being surrounded by the negative charges of the oxygen molecules. And so as a result, that allows us to dissolve material really, really quickly. And as we move materials around in our body, it's important that we're made of water, a very